Deep learning best practices and machine learning operations is something that needs to be worked on iteratively in each organization to find what works best depending on the specific technologies and use cases that you are working with. But it is, however, important to look at what resources are available to avoid reinventing the wheel from scratch. We're going to take a look at 3 different resources that I think we can consider as authorities within machine learning operations today. Starting with the most famous and well-known one, we have the Google's publications. For example, the Practitioner's Guide to Machine Learning Operations. This is a quite large white paper, but if you don't have time to read it all through, I would recommend reading at least the chapter about machine learning capabilities. In this chapter, they break down the different requirements from a machine learning or deep learning framework or environment, depending on the different activities. So for example, starting with the experimentation phase, we can see that they recommend using or implementing support for example, Python notebooks. But they also say that the ML environment should also let the developers or researchers write modular, reusable, and testable source code that is version controlled. So already at the experimentation phase, that should be incorporated into the system. We have data processing, and here you should be able to use pipelines to cater for large sets of data and long-running jobs. But it's also important to support interactive execution that should be well integrated together with automatic pipelines. So the automatic pipelines can, for example, be used to enable you to automatically retrain models whenever the data changes or whenever the code changes. For model training, it should be automated as much as needed. And we need to allow training both locally on our own developer computers, but also at remote servers for long-running jobs. Model evaluation is probably one of the things that I think is the most important in the machine learning development phase. And here we can see that we need to allow evaluation and use evaluation both during the experimentation phase, but also once the pipelines are automated or running in production. And we need to not only be able to see the results of the evaluations, but also to slice in the data so that we can understand the different group of data that is drivers for a specific result. We also need to track the results so we can compare different models and understand what the different changes makes to the results. And not only should we be able to see the results, but we also need tools to understand what is the cause of the results and what happens if different parameters changes. There are a lot of more capabilities outlined in this document. And the only one I think is not very generic is the model serving capability. Here it tends to be quite much focused at cloud deployment. So I think, for example, for a company that is deploying the models to the edge, for example, on cameras, there you have totally different needs for scaling, where the model scales linearly together with the hardware it is running on. But I definitely recommend reading through as much as possible of this document. And there are a lot of other publications from Google Cloud too on this topic. But the next thing we're going to look at is from the Continuous Delivery Foundation. So the main focus of the Continuous Delivery Foundation is more traditional DevOps, but they have a special interest group. So you will find a special interest group on GitHub. Most of the work is done through emails and the GitHub account. So this is the special interest groups for MLOps from the Continuous Delivery Foundation. And one of the interesting resources here is the roadmaps they are producing, the machine learning operations roadmap. Here I have some background about generally how they look at machine learning operations. And they also go through the different drivers that they think are important capabilities and requirements for machine learning operations. And what I find interesting about the Continuous Delivery Foundation is that they have a slightly different background, probably most of them coming from the DevOps and CI/CD world. They have a lot of knowledge and know-how in that specific areas, which can be applied to machine learning operations. So first they start with going through the different challenges that they want to solve within machine learning operations. So for example, we can see things here that differ between traditional CI/CD and continuous integration and testing in machine learning. For example, that we often have specific hardware accelerators, and these are expensive to incorporate in your pipelines and difficult to virtualize. So it might put different constraints on how you're able to do the continuous integration of your machine learning code compared to regular code. We also see things here about data, for example, versioning of data that is a bit different. That is a bit different than versioning. Here is the versioning aspects. And they are a bit different from the versioning of traditional codes. So for example, that the data volumes may be large compared to version control of code, but also that data may be sensitive. In some sense, you have already solved this for traditional code versioning, where you use different system to keep sensitive information like passwords separated from the rest of the checked-in code. But the case about data is that all the data might be sensitive, not only a part of it, which makes it even more complex to keep version in a way that is easy to use for the researchers and developers. So after going through the different challenges, they put down the technology requirements, which is a bit more technical considerations that needs to be respected when implementing solutions to it. So I think this is definitely interesting to read, especially from an automated testing and quality assurance point of view in the deep learning training and machine learning operations. So the third resource we are going to look at, it's not a specific organization, but rather a specific person. So the next source of information and inspiration, I think, should be Andrew Ng. And he's a professor at Stanford University. He's director of the Stanford AI lab. He's been previously head scientist or something like that at Baidu, and he's co-founder of the Google Brain project. So he has a lot of experience, both coming from academia and research, but also a lot of experience actually applying it to different business cases. And you can find material from him from a lot of places. For example, he has one company called DeepLearning.ai, which has a lot of course materials. And one of the courses here is machine learning engineering for production, the MLOps specialization. And if you go to this program, you will end up at Coursera. And if you want to access the material, you can actually do it for free here. If you just select one of the courses, you can audit the course. And this will give you access to all the material, all the course material. So both the videos, if you have the time to invest in actually looking through it all, that could be one interesting aspect. But more importantly, I think that you can access all the slide decks, which is hundreds and hundreds of slides in this very topic. So you can have those as go-to resources to look up specific information or get inspiration on specific topics. And one of the interesting aspects about Andrew Ng is that he is very data-oriented. So, for example, we can take a look at one of his slide decks here. And just going through it, we can see that it's a lot about data rather than the code and the models itself. So a lot of different interesting aspects about standardizing, making things more streamlined and more reusable. And here we can also see that he says that MLOps' most important task is to ensure consistently high quality data in all phases of the ML project lifecycle. So, for example, define consistency consistently. So this is very important. For example, if you scale from one to multiple annotators, that they are all following the same instruction and annotating in the same way. And this is also something that can be incorporated into the automatic pipelines to make it easier to get consistency in the data. You also need to cover all the important cases. And this goes back to having tools that not only allows you to visualize the data set as a whole, but also allows you to slice and dice in different parts of the data sets and compare different parts of the results and correlate them to the different parts of the data. And also the feedback loop that we get from MLOps pipelines, where we actually put the results from real-time production models back into the training pipeline, so we get a feedback loop that affects what data we are collecting and so forth. So in summary, I think that these three different resources are very interesting to use together, because I find the Google resource to be among the best for an infrastructure point of view. And the Continuous Delivery Foundations is interesting from an testability and quality assurance point of view. And Andre's material is very interesting from the data point of view. So other kinds of resources that you can use when implementing your own MLOps in your organization is to look at other companies that have successfully implemented MLOps at large scale in their companies. And this is something that I will go through in another video. So make sure to subscribe or to follow me on LinkedIn if you don't want to miss that information.